This
respect to
conference will now be
the
recorded.
CLCD, we started with the next peripheral of the module, which is nothing but CLCD. And CLCD stands for Character Liquid Crystal Display. And this CLCD will be able to display any characters on the screen and some of the special characters as well. So the CLCD has got 16 pins in total. The very first pin has been connected to VSS or ground. Second pin is connected to VCC or VDD or 5 volts. Third pin has been connected to V0, which is nothing but the contrast voltage. That is further connected to a potentiometer. Varying the potentiometer knob is going to increase or decrease the contrast of the data being displayed on the CLCD. Then there are 8 data lines varying from D0 to D7, which are connected to RD0 to RD7 pin of our microcontroller. So whatever data I want to give to the CLCD, I have to be giving it from RD0 to RD7 pin of the microcontroller, which is nothing but port D. Then this CLCD comes with its own microcontroller. So CLCD is capable of processing both the data and the instruction to tell the CLCD whether it is going to receive the data from D0 to D7 or it is going to receive the instruction from D0 to D7. We have a pin called RS, which represents register select, and that is connected to the RE2 pin of the microcontroller. So RS written with the value 0 represents whatever D0 to D7 is received is the instruction, and RS written with the value 1 represents whatever D0 to D7 is receiving, that's the data. So after that we have one more pin called as the read or write pin, which is used to monitor the D7 pin of the microcontroller. So we are going to monitor the D7 pin for the purpose of reading, because we have to know whether the data is done processing or not. We either can do it with the help of delay method, or we can use it with the help of let's say D0 bit, which is also called as busy flag. So if r/w is written with the value 0, then it is to indicate that D7 will be used for the purpose of writing. And if r/w is written with the value 1, it is to indicate that we are going to have D7 used for the purpose of reading. Okay. Now, what happens is, if we look at the hardware configuration, D7 is, sorry, r/w has been permanently connected to ground. So r/w keeps on should be used only for the purpose of reading. Sorry, D7 should be used only for the purpose of writing. So reading D7 bit will never be possible in the hardware configuration of ours, which is why we are going to make use of only delay method to know whether the data is being processed or not. And one more pin comes into picture, which is called as the enable pin. And this enable pin will let the user take his own time to provide the data to the CLCD. And once the user is done providing the data to the CLCD, he has to clock the enable. You have to toggle the enable. You have to make it 1. After some time, you have to make it 0. So that is to indicate the CLCD that I'm done giving the data. So then CLCD takes it and processes it, and accordingly it is going to take the action. So these are the pins of the CLCD. Then after that we started with the programming of the CLCD. CLCD can either be configured in 4-bit mode or it can be configured in 8-bit mode. So first, we started with the configuration of CLCD in 8-bit mode. For the initialization from the main function, we call the init config function, and from the init config function, we are calling the init CLCD function. Now, in the initialization of the CLCD, first we have to initialize the microcontroller of ours, that is the PIC microcontroller. Then we have to initialize the microcontroller of the CLCD as well. Now, there are pins of our microcontroller being used for the CLCD's configuration. One is RE2, the other one is RE1, and the port D for the data line. I have to set the direction of all those pins. So to set the direction of RE2, I'm going to make use of its data direction register, which is nothing but RIS-E2. In order to set the direction of RE1, I'm going to make its data direction register RIS-E1 used. Both of them are returned with the value 0 because I want both RE2 and RE1 to be treated as output. Then I'm going to write port D with the value, I want the pins of the port D to be treated as output. So I'm going to make use of its data direction register TRISD, return with the value 0x00. That is in turn making RD0 to RD7 as output. So this is the initialization associated to our microcontroller. Okay. Now I have to do the initialization of the microcontroller which is present on the CLCD as well. For that initialization, we are going to call the init display controller function. By the way, any doubts until this? Okay. Assuming that you people have got no doubts, I'm opening the data sheet of the controller which is available inside the CLCD, that is HD44780. So this is again a technical document. As I said, it just has around 60 pages. If you get enough time somewhere in the day, you please make sure you will be reading it at least for once. Okay, you can read it whenever you get time. Now, in order to make sure that I tell the CLCD that you have been configured in 8-bit mode, I have to follow certain instructions. Okay, some instructions have to be provided to the CLCD to tell that whether it has been configured in 4-bit mode or it has been configured in 8-bit mode. So actually you will end up seeing the set of instructions, some set of procedures to be followed. You can scroll down. I have actually gone through this document for few number of times by now, and I exactly know in what page the representation is available. So I'm directly jumping to that particular page. So this is initializing the microcontroller of the CLCD with the help of instructions. Now figure 23 is the set of instructions to be provided to the CLCD to configure it in 8-bit mode. Then figure 24 is to make the initialization with respect to 4-bit mode. So as of now, I have to configure the CLCD in the 8-bit mode. So to configure the CLCD in the 8-bit mode, which picture should I be referring? Picture number 23 or picture number 24? Yes, so we have to refer picture number 23 in order to configure the CLCD in 8-bit mode. So this in fact is picture number 23, which tells the instructions to be followed in order to configure the CLCD in 8-bit mode. Now I have to follow these procedures. Okay, whatever procedure you see, I have to follow it. Now to start with, initially after you power on, okay, once the board has been powered on and once the CLCD has been switched on, the very first step I have to do is I have to wait for more than 15 milliseconds after VCC raises to 4.5 volts. Also, it is asking me to wait for more than 40 milliseconds after VCC raises to 2.7 volts. So approximately, this is asking me to wait for 55 milliseconds of time. Okay, in total, it is asking me to wait for 55 milliseconds of time initially when the board has been powered on. Now, I will not literally wait for exact 55 milliseconds of time because the moment I turn on the board, I will not immediately dump the code into that particular board. So I'm assuming I will take some amount of time to have my board turn on, and I take some amount of time to load the program into that particular board. So assuming that instead of me waiting for a total of 55 milliseconds, I will wait for an average time which is nothing but 30 milliseconds. Okay, so I'm going to wait for an average of 30 milliseconds. Okay, now whenever I have to wait is like I'm creating a delay. Okay, so wait is like I'm trying to create a delay. So whenever I am trying to create a delay here onwards, remember I'm going to make use of a built-in function. Okay, so we have a built-in function associated to our microcontroller, which is capable of generating a delay. Okay, and the name of the function is double underscore delay. Okay, why is it both 4.5 volts and 2.7 volts? That is how the CLCD has been designed. That is how the microcontroller of the CLCD is being designed. So I have to wait for 15 milliseconds after VCC. Initially, if I provide, immediately it will not give 0 volts. So gradually it is going to accept the power. CLCD accept the power gradually. So I'm going to start with 0 volts. Immediately I don't provide 5 volts. So I have to wait till 4.5 volts. I have to wait till the voltage reaches 4.5 volts. Then I have to wait for 15 milliseconds. Then I have to wait for 40 milliseconds after the power raises to 2.7 volts. Okay. So I'm going to wait after 2.7 only it raises to 4.5 volts. Okay. So I'm going to wait for a maximum of 30 milliseconds in my case. It is like an average of 15 and 45. Now, whenever, as I said, whenever I have to make use of any delay to be introduced, I make use of a built-in function called double underscore delay. And for this delay, I have to specify the unit as well, whether it is the milliseconds or microseconds or nanoseconds, I have to specify. So seconds here is the milliseconds. I have to wait for a duration of 30 milliseconds. So I have to provide that amount in the parenthesis. I have to pass it as an argument. So double underscore delay underscore milliseconds of 30 is going to generate a delay of 30 milliseconds. Okay. Now one more important thing. If you have to, yes, this is blocking delay. Okay. So this is blocking delay. It is going to have the system block for 30 milliseconds. But we don't have an option. When you are working on CLCD, you want to focus on something being displayed on the CLCD. This amount of time should be given to the CLCD. So I cannot implement non-blocking delay. Okay. So delay milliseconds for a duration of 30 milliseconds. I'm trying to generate a delay of 30 milliseconds. Now, one more important thing you have to remember here is, if you are supposed to make use of this built-in function, this built-in function will be able to generate the time according to the oscillating frequency of your device. So it is compulsory that you specify the oscillating frequency of your device with a macro called external frequency. I'll show you that. You can see here this external frequency. So this is the macro you have to use to specify the frequency of your microcontroller with which it works, the clock frequency. So it is 20 megahertz. So I have 20 followed by 6 zeros written here. So for the delay function to work, it is necessary that you specify the crystal frequency of your microcontroller. Now the first thing in the init display controller I'm doing is double underscore delay underscore millisecond function call by passing 30 as an argument. So this is going to generate a blocking delay of 30 milliseconds. Okay, so this generated a delay of 30 milliseconds. Next, after that, whatever I have to specify, all other things I have to specify it to the CLCD. So, uh, okay, can you repeat the crystal frequency? Okay, repeating again. So whenever you have to make use of the delay milliseconds function, okay, so if you want delay milliseconds or delay microseconds, delay nanoseconds, whichever functions you want to use with respect to the delay, they all will be able to generate the required delay according to the crystal frequency of your device. So it is necessary that you specify the crystal frequency with the help of a macro called underscore xtil underscore frequency. And that is our microcontroller works with a frequency of 20 megahertz. So I have followed 20 megahertz. Okay. Why 30 milliseconds? As I said, I have to wait for an average of approximately 55 milliseconds. I'm taking a average that is 30 milliseconds. But where delay using extra frequency directly if we give as a macro. So delay milliseconds is a function. Okay, it's a built-in function. You have to know how the function is working. It is impossible for us to look at the definition of the built-in functions. We should just be able to use them however it is required. So for the delay millisecond function to work, it needs the crystal frequency to be specified using this macro. So using this crystal frequency, your delay millisecond function will be able to generate the delay of the required time you're specifying. So that's a built-in function. It's like printf, it's like scanf. You will not be able to see the definition of the function. You just have to follow the procedure of how to use it. Okay, fine. So let us proceed. Okay. So yes, Saurabh, 15 plus 40 is 55. Its average is approximately 20, let's say half of it. So 20, 26, 27.5 will be its average. So I'm taking 30 in random. Okay. So I'm going to wait for 30 milliseconds. Then I have to instruct the CLCD that I'm going to configure it in 8-bit mode. Okay. So for that, I have to follow some set of instructions to be provided to the CLCD. Now, these are the instructions to be followed. Starting with, this is the first instruction to be provided to the CLCD. Now, if RS return with the value 0 represents what? If RS is written with the value 0, what does it represent? So yes, whatever will be provided from D0 to D7, whatever CLCD will receive from D0 to D7 should be treated as an instruction. So first I have to specify RS with the value 0. Then R/W is anyways always 0, so that is not going to differ. Then DB0 to DB7 means data bit 7 to data bit 0 has to be provided with 0011 and the 4 don't care bits. Okay. Now, whenever I want to specify something to the CLCD, whenever I want to write something to the CLCD, I'm going to call a function called CLCD write. Okay. I'm going to call a function called CLCD write. So what the CLCD write function will do, I'll specify what is the definition, I'll show you. But meanwhile, Please understand, anything I want to write to the CLCD, I'm going to call a function called CLCD write function. Now to the CLCD write function, I'm first going to specify what is the RS value. Then I'm going to specify what is the data I'm supposed to write. Okay. To the CLCD write function, I will first specify the RS value. Then I'm going to specify the data to be written. So in this case, if you observe the CLCD write function, first it takes the argument. No, it's not a built-in function. I'm supposed to write it. So CLCD write function will take RS, which is nothing but 0. Then it is going to take the data which needs to be displayed, which needs to be given to the CLCD. It is 0011 and the 4 don't care bits. So these don't care bits can either be taken with the value 0 or it can be taken with the value 1. Okay, so don't care bit anyway at the end. So you can either have the data return as 0 or you can have it return as the 1. So what I will do is, instead of me having return as 0 or 1, I will follow the same sequence as the previous data. So here I'm going to write 0011 to this place also. Okay, so 0011, here also I'll write 0011. Okay, in fact, CLCD write function has to be first return with data, then it has to be RS. Anything, it is anyways a user defined function. It is completely up to the user's choice. So I just saw in my function I have first received data, so I'm going to write data. So the data I have to be providing to the CLCD is 0011 0011. Can you tell me the hexadecimal equivalent? So I have 0011 here already. I followed the same to be written here also as 0011. Okay, it's a don't care bit. I can have anything written. Okay, so that is 0x33. So I should pass 0x33 as an argument. Okay, and I have to pass 0 as an argument. To the CLCD write function, I'm passing 0x33 and 0. Now, if data we are writing to the CLCD, then RS should be 1, right? Yes, so that is data. This what you are giving is an instruction to the CLCD. You can see I'm initializing the CLCD with the help of instructions. So whatever you are providing from RD0 to RD7, it is nothing but the instruction which will be collected by the CLCD. So you have to write RS with the value 0. They are clearly specifying RS has to be returned with the value 0. Okay, so I'm calling CLCD write function by passing 0x33 and 0. Why db find? That is the instruction to be followed. Okay, so whoever is the manufacturer of the CLCD's microcontroller, he has given me these instructions to be provided to the CLCD for the sake of initializing it in the 8-bit mode. So there is no reason why 11 is specified here, or there is no reason why don't care is specified here. Okay, so for every instruction you are providing, it is like a code being provided. Okay, it's like a code you are specifying. So when I write 0x11 and 4 don't care bits as an instruction, now CLCD is trying to cooperate and it is trying to get initialized in the 8-bit mode. Okay. Now, yes, I should write the CLCD write function with 0x33 and 0. So let me show it here. I'm calling CLCD write function by passing 0x33 and 0. So that 0x33 is returned as a macro called 8-bit mode. and 0 is written as a macro called instruction mode. You can observe it in clcd.h. So 8-bit mode is 0x33 and instruction mode here is 0. Okay, I'm calling CLCD write function by passing 0x33 and 0 as an argument. Are you able to get this? Okay. Now after that, I have to wait for more than 4.1 milliseconds. Okay, I have to wait for more than 4.1 milliseconds. Now for me to wait for more than 4.1 milliseconds, I have to again make use of the delay milliseconds function. But this function will take only integer as an argument. Okay, so if I pass 4 here, it will give me a delay of 4 milliseconds. I will not be able to pass 4.1. So that is why I'm calling delay microseconds function by passing 4100 as an argument. Okay, I'm passing 4100 as an argument to the delay microseconds. So this is going to give me a delay of 4.1 milliseconds. Okay, so this gives me a delay of 4.1 milliseconds. Next, after that, again, I have to write RS with the value 0 and I have to write DB0 to DB7 as 0011 and again 0011. Same instruction. Okay, 0011, 0011, which is 0x33. So I'm calling the CLCD write function by passing 0x33 as an argument and also 0 as an argument. So 0x33 is 8-bit mode and 0 is instruction mode. After that, I have to wait for more than 100 microseconds. So I'm calling delay microseconds by passing 100 as an argument. Okay. Next, after that, again the same pattern. RS is returned with the value 0 and DB7 to DB0 has to be returned with 0x33. So I'm calling CLCD write function by passing 0x33 as an argument and 0. Okay. So this much we finished. Any doubts still here? Any doubts still here? Okay. Proceeding ahead, after that, I have to provide this instruction to the CLCD. Now, after I provide this, I have not provided any delay here. So, just for the safety purpose, I'm going to give a delay of 1 microsecond. Okay, a small delay of 1 microsecond. Next, I have to write CLCD with RS return with the value 0. Then DB7 to DB4, it is fixed to 0011. Then I have something called as N and F and two don't care bits. Now what does this N and F represent is? N represents number of lines and F represents the character font size. Okay. So N represents number of lines, F represents the font size. Now if you observe the CLCD which is available on this board, can you see there are two lines here for the sake of displaying the data? Can you see there are two lines? Yes. So I can choose whether to have the data displayed in two lines or I want the data to be displayed on a single line. So that is up to me. Now I have to say whether I am going to choose two lines or I am going to choose one line with the help of N and F bit. Okay, so we have N and F bit. So I should be able to specify whether I will be using a single line or I will be using two lines. For that, I have to go to the same document. So I have to refer what does this N and F represent. So you can scroll down a little up and you will end up getting a table scene. Okay, so I'm scrolling down, scrolling up a little. Okay, something like this. So I have N and F table representing here. Now if N is 0 and F is 0, you are going to select one line. Okay, you are going to select only one line, and characters will be displayed in 5 cross 8 dots. Okay, so characters can be displayed in 5 cross 8 dots. See what happens. So you can have a character displayed in 5 cross 8 dots, or you can have a character displayed in 5 cross 10 dots. If you have a character displayed in 5 cross 10 dots, you can use only one line. But if you have a character displayed on 5 cross 8 dots, you can have two lines used at a time. Now, I always want to take a benefit of both the lines. Okay, I always want the benefit to be taken for both the lines. So I want to choose 5 cross 8 dots, and I want two lines. Now, to choose 5 cross 8 dots of two lines, what should N and F be returned with? What should N and F be returned with? It has to be returned with 1 and a don't care bit. Okay, so it has to be returned with 1 and a don't care bit. Now, what is that 1 and a don't care bit? I'm going to substitute here. N has to be returned with 1 and F has to be returned with a don't care bit. Okay, so let me replace it here. N has to be returned with 1 and F has to be returned with a don't care bit. So let me write it as 0. Here also I'll take a 0. Here also I'll take a 0. Can you tell me what is the hexadecimal equivalent of this data to be written? 5 cross 10 is larger, or 5? Obviously 5 cross 10 is larger. You will use 10 dots to display one data. Then how? One line for that. 5 cross 10 is bigger. So bigger means you can use only one line, no? 5 cross bigger, 5 cross 10 will occupy 10 dots vertically, 5 dots horizontally. So approximately, let's say I have 16 dots all over. Okay, let me show it like this. So if the CLCD is like this, I have 16 dots like this written vertically. Okay, it's like 16 dots I have got written vertically. So if I use 5 cross 10 dots, 5 horizontally and 10 vertically, I will be able to use only one line. I will not be able to use two lines in that case. Are you able to follow this? Okay, I'll show it here. You see something like this, or I think I'll show my CLCD itself. So on my CLCD here, I have 16 dots written like this vertically. Okay, so like this I have 16 dots vertically. I have 5 dots horizontally written for every box you see here. So if I use 5 cross 8 dots here, I can display one character here. I can display one more character here. 5 cross 8 dots, 5 cross 8 dots. One character up, one character low. If I use 5 cross 10 dots, I am going to occupy half of the second box also, like this. I can display only one character. I cannot display one more character here. In that case, I should use only one line. If I'm using 5 cross 10 dots, for one character to be displayed, I can use only one line. So if I use 5 cross 8 dots, I can use 2 lines to have the data displayed. Are you getting this? Okay. So I want to take the advantage of both the lines. Okay, I don't want a single line to be used because I have 2 lines. Let me take the advantage of both the lines. So to have 2 lines, each of 5 cross 8 dots to be used, then I am supposed to write n with the value 1 and f with the don't care bit. So I wrote n with 1. For the don't care position, I wrote zeros. Okay. So here I wrote it with 1. For the rest of the don't care, it is 0. Can you tell me what is the hexadecimal equivalent of the data to be given to the CLCD here? Yes, 0x38. So RS has to be returned with 0 and data has to be provided with 0x38. So that is what I'm doing here. I'm passing 0x38 and 0 as an argument. So 2 lines 5 cross 8 dots 8 bit is representing 0x38. So I'm calling CLCD write function by passing 0x38 and 0 as an argument. Next, after that, the next is, this is to turn off the display. Should I turn off the display right now? So this instruction I'm providing is to turn off the display. No, I don't have to turn off the display, so I'm not going to use it. Okay. So this instruction, this one, I'm not going to follow. Then the next one is to display clear. In order to clear the display, so I have to write RS with the value 0 and the data has to be 00000001. So that is to clear the display. So I am calling CLCD write function. Clear display screen is representing 0x01. So this is 0x01. Okay, and 0 as an argument. Then between the two instructions, I'm giving some random delay of 100 microseconds and 500 microseconds. If you want, you can reduce. If you want, you can increase. Okay, so just randomly, I'm giving a delay of 100 microseconds and 500 microseconds. Now, after that, the next instruction given here is entry mode set. Okay, so that I don't have to set the entry mode. So this also I'm not following. I have written one more instruction, that is to turn on the display and turn off the cursor. So if you read the data sheet, it's a homework for you. You read the data sheet. Similar to this, you will end up getting the instruction to be returned to the CLCD if you want to turn on the display and turn off the cursor. So I did a small study on the sheet. I found that to turn on the display and turn off the cursor, I have to pass 0x0c as an argument. So it is the task of yours to find out where is this available on the data sheet. So to turn on the display and turn off the cursor, I have to provide 0x0c as an instruction to the CLCD. So I'm calling CLCD write function by passing display on and cursor off in the instruction mode. Okay. Then again, I'm going to provide a delay of 100 microseconds. So that is what we have followed here. Okay. So if you can wait, if you can observe here. So this is the instruction I have followed one after the other. Okay. So all of the instructions are being written here. Okay. So first delay, then I'm calling CLCD write function. Whatever I want to write to the CLCD, I'm writing it with the help of CLCD write function. I'm first specifying the data to be given. Then I'm specifying the mode, whether it is the data mode or the instruction mode. Is that clear? Okay. All right. So let us proceed. Now, the next thing we have to understand is what is the CLCD write function actually doing? So yesterday, why delay of 500? So I said I'm just giving a random delay. If you want, you can increase. If you want, you can decrease. So there is no specific reason for giving 500 microseconds of delay. Okay. So yesterday, as we discussed, this is the procedure I have to follow whenever I have to write some data to the CLCD. So anything I want to provide from D0 to D7 of the CLCD. So if you observe the pictorial representation, anything I have to provide to the CLCD, it has to be accepted by D0 to D7 pin of the CLCD. So I can write to the D0 to D7 pin of the CLCD with the help of RD0 to RD7. Similarly, if I have to write to the RS, I have to write it to the RE2 pin. If I have to write it to the enable, I have to write it to the RE1 pin. So CLCD write function is very similar to that. So what we have done here is in the CLCD write function, you can see the CLCD write function is accepting two inputs. First one is a character variable called byte. Second one is a character variable called mode. Okay. Now following the same procedure as I wrote here, first whatever is the RS, I have to write it to the RS pin of the CLCD. Now to which pin of the microcontroller RS of the CLCD is connected to? It is RE2 pin. So whenever I want to write to RS, I have to write it to the RE2 pin of the microcontroller. So whatever is the mode I have received, here I will pass either a 0 or a 1. So 0 if it is an instruction, 1 if it is a data. So that will be collected by mode here, and that mode has to be returned to the RS pin. Now CLCD RS is the macro which represents of RE2 pin of the microcontroller. So here I'm writing into the RE2 pin whatever is the mode. So whether the mode is 0 or 1, that is returned to the RE2 pin of the microcontroller. Can't we write directly to the CLCD? How will you write directly to the CLCD? It's a separate microcontroller. Okay, tell me how will you be able to write it? So you have D0 to D7. Are you programming the microcontroller of the CLCD independently? Are you running your program on the microcontroller of the CLCD? No. So that is not possible. So see, if you literally have to write, you have to program its microcontroller separately. If you program the microcontroller of the CLCD separately, you will be able to write from D0 to D7 directly. Now we are not programming the microcontroller of the CLCD independently. You are using the CLCD with the help of the PIC16F 877A microcontroller. So that is why anything you want to write to the CLCD, it has to be with the help of the port pins of the PIC microcontroller. Are you getting this? Direction also we are writing to RE2. What direction? Input or output? No. When did we write to RE2 and RE1? Did we write it to RE2 and RE1? As you people are like, you're getting so much confused. Right, I did not write to RE2 and RE1. Can you observe? This is the reason why I'm writing what it is representing every time. Please see the initialization. Did I write to RE2 and RE1? I wrote it to the. See, this literally says you people are not paying attention to the basics. So if you have to set the direction, I will never use RE2 or RE1. So direction, whether it is input or output, will only be specified with the help of tris register. Are you people literally feeling it difficult to follow? This is like the very basic programming. Guys, I'm asking you, are you feeling very difficult to follow this? Okay, so fine, like let me continue. So I'm proceeding ahead. So whenever I have to write to the CLCD, yesterday I made a note here, if you have not forgotten. First, I have to specify to the RS pin whether it is the data or the instruction. Then whatever input I have to provide, I have to write it via the port B. Then I have to clock the enable. So this is what I have to follow whenever I have to give some data to the CLCD. If I have to write it to the RS of the CLCD, I have to write my data to the RE2 pin of the microcontroller. If I have to write it to the enable, I have to write it to the RE1 pin of the microcontroller. If I have to write it from D0 to D7, I have to write it from RD0 to RD7 pin of the microcontroller. So that is what we have followed here. Whenever I want to write into the CLCD, I call CLCD write function by first specifying the data I want to write, then specifying what is the data, whether it is the data or the instruction. So that is being collected as an argument to the byte and mode, the two character variables in the CLCD write function. Now, whatever I want to write to the CLCD, that is being collected by byte. Whatever mode I have to specify, that has been collected to the mode. Now, CLCD RS is the macro, which is representing RE2 pin of the microcontroller. So, I'm writing RE2 with the value mode. Then, whatever data I have to write it to the port D of the microcontroller. So that port D is named as CLCD data port. So whatever port D I have, that port D is returned with 0x33. If I want to write 0x33 and as a instruction, okay, 0x33 as the instruction. So that data is returned. Then I have to clock the enable. So RE1 is where the enable pin of the CLCD is connected to. RE1 is returned with 1. I give a small delay and RE1 is returned with 0. The moment you clock the enable bit, the microcontroller of the CLCD will understand that the user is done giving the data. So the microcontroller of the CLCD will start processing the data. Now we got to know from the data sheet that the CLCD, the microcontroller of the CLCD, will require approximately 4.1 millisecond to process any of the data. Okay, so we got to know it from the data sheet that the microcontroller of the CLCD will approximately need 4.1 millisecond for processing the data. So I'm going to call delay microseconds because that is the only way I can know whether the data is processed or not. It is with the help of delay method. So delay underscore microsecond, I'm calling the function by passing 4100 as an argument. So I'm providing enough time for the CLCD to process the data, whatever I'm giving it. Now, once the data is processed, it is going to take action accordingly. Okay. So once the data is processed, it will be taking the action. So that is CLCD write function, which is used to write any data to the CLC. Is this clear? Okay. So please take a break of 2 minutes. If you want noise, somebody's mic is on. Vinita's mic is on. Okay. So I hope you are clear now with the CLCD write function and the init display controller. So let's take a break of 2 minutes and we'll continue. Okay, can we proceed? Hmm. Why delay in CLCD write? So delay in CLCD write function, as we spoke yesterday, you have to let some amount of time for the CLCD to process the data, whatever you have written. So we can monitor whether the data has been processed or not using two ways. One is delay method, the other one is polling method. So polling method is ruled out because r/w pin is permanently connected to ground. So you have to use the delay method itself. So after I'm done giving the data, I have to wait for certain amount of time to make sure whatever data is given to the CLCD is being processed by it. Okay. Then whatever we written previously from seeing the data sheet like instructions, all that is only to tell it in 8-bit mode. 5 cross 8 and to turn on CLCD. It's common every time, right? Like the driver code. And if we want to write a data by setting RS is equal to 1, we can write using the function you are telling now. Am I correct? Yes, it is. Why 4100 as the delay? We looked into the data sheet and we found out that the maximum amount of time your CLCD might need to process any given data is 4.1 milliseconds. So I cannot pass 4.1 millisecond as an argument to delay milliseconds, which is why I'm calling delay microseconds passing 4100 as an argument. Okay. Answer using delay method, we are giving delay manually. Sorry, as we are using delay method, we are giving delay manually. Yes, yes. So we have to use delay method itself and we have to provide delay manually itself. Okay, fine. So moving ahead, after this, I'm done with the initialization of the CLCD. I'm also done with the initialization of the microcontroller which is available on the CLCD. Next, coming back, please understand here onwards, whenever I want to write one character on the CLCD, to write one character on the CLCD, I would say to display. Okay, so to display one character on the CLCD, I'm going to call the function CLCD put ch. Okay, so whenever I have to display one character on the CLCD, I call CLCD put ch function. Similarly, to display one, let's say, to display a string. Okay, so to display a string on the CLCD, I'm going to call CLCD print function. Okay, so I'm going to call CLCD print function. To display one character on the CLCD, I call CLCD put ch function, and to display a string on the CLCD, I'm going to call CLCD print function. So I have two separate functions written here onwards. Now assume on the CLCD, I want to display character A. Okay, so I want to display character A on the CLCD. Now if you observe, okay, fine. So this is the CLCD. Assume this is the CLCD, and the CLCD has two lines. Okay, so this is the CLCD, and CLCD has two lines like this. Now, the very first line of the CLCD is having 16 characters. If you can count here, clearly observe and count. I will have 16 boxes on the first line, 16 boxes on the second line. So I will have 16 characters on line 1 and I will have 16 characters on line 2. So this is my CLCD, which is having which can have 16 characters displayed on each line. And I'm dealing with 2 lines here. Okay. Now let me have the position return for 16 characters starting from 0. So I can have one character printed on 0th position, then first position, second position, third position, fourth position, so fifth position, sixth position, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Okay, so I will have 2 lines. Let's say this is line 1 of the CLCD and this is line 2 of the CLCD. Okay, so this is line 1 and this is line 2. Now assume I want to display character A on line 1 fourth position. Okay, I want to display character A on line 1 fourth position. Now how will you specify is the very first line's address is 0x80 and the second line's address is 0xc0. Okay, so first line's address is the address of the very first line is 0x80, address of the second line is 0xc0. Now tell me, if I have to have character A displayed on line 1 fourth position, what is its address? If I should have character A displayed on line 1 fourth position, what is its address? 0x80 of 4, 80 of 0, 80 of 1, 80 of... So can I say 0x84? Yes. So I have to call CLCD put ch function by passing character A, whatever I want to display, and the address in which I want to display. So let's say 0x84. Correct? So I have to say it like this. I call the CLCD put ch function by passing character A and 0x84. Now tell me, I want character B to be displayed on line 2 8th position. Okay, here I want character B to be displayed. So what should I do here? What is the address to be passed? CLCD put ch function. I want to display character B on the address 0xc8. Now don't you think it is quite challenging for me to remember these addresses and positions all the time? So every time I have to do the mathematics, I have to provide. Instead of that, yes, I will go for a macro. So I will go for a function like macro. As define, okay, a function like macro, as define. So line 1, okay, which collects x as an argument. So whenever I call the macro, it replaces it with 0x80 plus x. Okay, 0x80 plus x. Similarly, as defined, let's say line 2 specifying x and 0x c0 plus x. Okay, so instead of me calling CLCD put ch function by passing 0x84 as an argument, I can call CLCD put ch function by passing character A and let's say line 1 fourth position. Okay, so I can call CLCD put ch function by passing character A line 1 fourth position. Okay, now when I call line 1 fourth position by passing 4 as an argument, it gets replaced with 0x80 plus 4, which is nothing but 0x84. Similarly, I can call CLCD put CH function by passing character B. What should I pass as the next argument? For 0xC8 being the address, I have to pass line 1, line to 8th position. Correct? So I have to pass line to 8th position. So like this, if you want one character to be displayed, I can call CLCD put CH function. Now what the CLCD put CH function does is, okay, so return type of the function is void. Function's name is CLCD put CH, okay, and it is going to first collect the character data, then it is going to collect the address. Okay, first it is the data, then it is the address. Now what I have to do in the CLCD put CH function is, okay, so something like this. In the CLCD put CH function, I have to call CLCD write function. First, I have to tell the CLCD that I will give you an address. So I have to pass address and 0 as an argument. Okay. So address whatever I want, I will give it as an instruction. So looking at that address, CLCD will be prepared that the next data I'm going to display is in this address. Then I have to call CLCD write function by passing data and 1 as the RS. Are you following this? First I call CLCD put CH function by passing what data I want to display on the CLCD and in what address I want the data to be displayed. I'm just calling CLCD put CH function. Now CLCD put CH function should have the data returned to the CLCD. Now to write the data to the CLCD, we already have CLCD write function. I first specify the address in which I have to perform the write operation, and that address I am going to pass it as an instruction. Now what CLCD write function does? First let me write the flow. First you call CLCD put CH function. From the CLCD put CH function, control will come to the function's definition. Then I'm calling CLCD write function. Control will go to the CLCD write function. So this is CLCD, let's say, write function, which is collecting two arguments. One is character byte, the other one is character mode. Okay. Now CLCD write function, what should it do? Whatever is the mode, I have to write it to the RS pin. So RS has to be returned with mode. Then whatever is the data, I have to write it to the port D. Okay, so that is byte. Then after that, I have to clock the enable. So E has to be returned with 1. Okay, E has to be returned with 1. Then I have to give a small delay of, let's say, few microseconds. Okay, let's say 100 microseconds. I'm going to give the delay. And after that I have to again clock the enable. So I have to write E with the value 0. Okay. Then I have to give the time for the microcontroller of the CLCD to process the data, which is 4100 microseconds. Now I cannot write directly to the RS. Where should I write? If I have to write it to the RS, to which pin of the microcontroller I have to write? Yes, it is RE2 pin. I cannot write to the enable. It has to be RE1 pin. So this also has to be RE1 pin. Now are you able to understand how will that print the data on the CLCD? So first we store address in port D as byte. Port D is equal to byte when passed as instruction, then write data at that instruction. Okay. First you are going to write the address. See, whatever is the address 0x84, assume that will be passed as an instruction to the CLCD. Now CLCD's D0 to D7 pin, this D0, okay, I closed it. The D0 to D7 pin of the CLCD receives the address 0x84 as an instruction. Now looking at the address 0x84 as an instruction, CLCD will understand that somebody is trying to write into the address 0x84. Now it will pay attention. Then you are calling CLCD write function by passing the data you want to print and 1, rs as 1, which is nothing but data. Now, the moment RE2 receives the value 1, that is RS receives the value 1, CLCD will understand somebody is giving me the data to be printed on the address what they specified. Now that data will be received from D0 to D7, and once you clock the enable, the data will be processed by the CLCD and that data will be displayed on 0x84 address. Okay, so that is how CLCD put CH is working. Now whenever I have some data to be displayed, some string to be displayed, I call CLCD, let's say CLCD put print function. Okay, it is CLCD print function I am supposed to pass whenever I have some data to be displayed. Now assume the data I want to display is string called hello on line 1. Okay, on line 1, let's say 7th position. Okay, so line 1, 7th position. What is the address of line 1, 7th position? What is the address of line 1, 7th position? Hello. Okay. So I want to write hello here. H, then at 9th position E, 10th position L, 11th position L, and 12th position O. Okay, so here I want to write a O. Okay, so that is the task I want to do. So I'm calling CLCD print function by passing hello on line 1, 7th position. Sorry, yes, it is 7 here. Okay, so I want to print it on line 1, 7th position. So now I'm calling CLCD print function. Now how CLCD print function works is, to start with, let me write this down here. Okay, so CLCD print function. So void, then CLCD print function. So it collects two arguments. One is character, let's say pointer called str, and character address. So this time what I'm passing is more than one character. So it should be collected into a pointer variable. Now what this does is, one second. Okay, so I'm going to write CLCD print function here. So what happens in the CLCD print function is, you have to take a while loop while star str is not equal to null. Okay, so until it is not equal to null, I have to print it. So how to print? First, I have to specify the address. So I'll call CLCD write function by passing the address and also as an instruction. Okay, So I call the CLCD write function by passing the address as an instruction. Then I call CLCD write function by passing the star str and data. Okay. So after this, I have to increment the address addr plus plus because I have one character at a time to be displayed in one address str plus plus. Okay. So first, for example, if it is hello to be displayed on line 1 7th position, that is 0x87 address. First, H will be passed as an this str collects the address of hello and addr collects the address 0x87. So first, star str gives me character H not equal to null is true. So I first give the address 0x87, then I pass the character H that will be displayed on the CLCD. Then address plus plus str plus plus. Address plus plus will be 0x88 and str plus plus will be the next address of the string. Now star str gives me character E not equal to null is true. Again, I will pass 0x87, 88, then I pass character E. So address plus plus str plus plus. This continues. And this is going to continue until you reach the null character. So this is going to continue until it reaches the null character. Okay, so this is going to reach until it reaches the null character. And in fact, what the what the CLCD says is, if you are giving me continuous address again and again, it tells you don't have to give the address for multiple times. Okay, so it tells don't give me the address for multiple times. You just tell me for only once. I will be able to take the address continuously one after the other myself. So that is what the CLCD says. So you don't have to give address plus plus and all. So that is not at all required. Okay. So it says you don't have to specify all of this. You just give me the string, I mean the character one after the other. I will take care of the address. Okay. So this is your CLCD print function. So you don't have to repeat the procedure again and again. So this is CLCD print function. Okay. So let me save this CLCD functions. Babu, I'm not getting what you're asking for. Are you able to understand this? Okay. Now, as we have null character, no need to give end address for microcontroller. It stops when null. No, I'm not even giving the next addresses. I'm giving only the first address, that is 0x87. After that, I keep giving only the character one after the other. Okay. So in that case, the address will be updated automatically by itself. Now observe, I'm trying to print character A on line 1 4th position. I'm trying to print hello on line 2 2nd position. So CLCD put CH function, CLCD print function. You can look at the definition of both the functions. CLCD put CH function. I'm passing the address and the data, one in the instruction mode, the other one in the data mode. Then CLCD print function, I'm giving the address for only once and character till it reaches the null. So whatever I wrote it here, the same I have converted there also. Okay. So let me build this and show you the output. I'm expecting character A to be printed on line 1 fourth position and hello to be printed on line 2 second position. So I'm building the project. Okay, so some small warnings are given. Let us just ignore the warnings. Okay, so build has been successful and loading is also completed. So let me load the hex file here. File, load hex. So that is CLCD's 8-bit driver. Okay. So under CLCD, we have CLCD sources, 8-bit driver, distribute, default, production, the hex file. Can you see character A on line 1 fourth position and hello on line 2 second position? Okay, so that is configuration of CLCD in 8-bit mode. Any doubt in this? Okay. Now, I will not explain you the 4-bit mode in detail because every function in 4-bit mode remains the same. Let me just open the driver and show you how the 4-bit mode looks like. The only difference in 4-bit mode is, first and the foremost, the sequence to be followed to initialize it in 4-bit mode is different. This figure number 23 was to initialize it in 8-bit mode. So for 4-bit mode, you have to follow these instructions. Okay. So it tells only from DB4 to DB7. The rest of the things you can add zeros here. Okay. The rest of the things you can add zeros here. Now this remains the same, the procedure you have to follow remains the same. Now let me show you the main function. Here in the main function, first I am calling CLCD initializing function, and inside while of 1, I am trying to print character 1 on line 1 fourth position and word from line 2 fourth position. So if you look at the functions, the init CLCD function remains the same. Actually, you have to set the direction of RD4 to RD7 only. Okay, but here we are setting the direction of RD0 to RD7. So if you are using CLCD along with some other peripheral, it might create a disturbance. So if you are using along with some other peripheral, please set the direction only for RD4 to RD7. So in this case, we have written trisD with the value 0x00. I'm setting the direction for RD0 to RD7. That is in fact not exactly correct to be followed. So anyways, because I'm not using any other peripheral along, so this should not make any difference. So RD4 to RD7 should only be initialized as output. Okay. Next, CLCD put CH is the same. CLCD print function is also same. And init display controller, this follows the sequence according to what is available in the sheet. Okay. So that you can cross check later. Now the only difference in 8-bit mode to 4-bit mode is, instead of you using all 8 pins, you are going to use only the upper 4 pins. These 4 pins will only be used. RD4 to RD7 will only be used to provide the data to the CLCD. Okay. So you will not use RD0 to RD3. You will use only RD4 to RD7 to have the data given to the CLCD. So when you are supposed to write the data to the CLCD, I have to make use of only 4 pins RD4 to RD7. Hence, the only difference you will see is in the CLCD write function. So you are not writing all 8 bits at once to the CLCD. Instead, you are writing upper nibble first, then you are going to write the lower nibble. Okay. So first we write the upper nibble, then we are going to write the lower nibble. So assume I have the data, let's say 0x35 to be returned as an instruction. Okay. Assume I have the data 0x35 to be returned as an instruction. So CLCD write function has received 0x35 and 0 as an argument. Now first, CLCD data port, okay, it is actually representing port D, but you are not supposed to use the complete port D. You have to use only RD7 to RD5 to have the data transmitted. Sorry, RD7 to RD4. Okay, should only be used to have the data given to the CLCD. Now first I have to provide the upper nibble. Now if I have to get the upper nibble from this data, I will do byte and with 0xF0, correct? So when I do byte and with 0xF0, so it is 0011, 0101. So that is 0x35. If I AND it with 0xF0, I will end up getting 0011, 0000. Do you agree with that? So I end up getting the upper nibble. Now this upper nibble should be given from RD4 to RD7 of your microcontroller. So I write CLCD data port is equal to byte and with 0xF0. So this goes to RD7, this goes to RD6, then RD5, RD4. Don't you think with the help of RD4 to RD7, I transmitted the first nibble 3? Did I not transmit RD4 to RD7? Sorry, did I not transmit 3 from RD4 to RD7? Okay, so fine. Then after that, F0 write to take 4 bits, you took E0. Sorry. When did I take E0? Where have I written E0? I've taken F0 only. No, this is 0xF0 only. Where are you seeing E0? Okay. So 0xF0 I'm adding to get the upper nibble and I'm providing it to the port D. So using RD4 to RD7, I pass the upper nibble 3 to the CLCD. Then I have to clock the enable. So E has to be returned with 1. Give a small delay. E has to be returned with 0. Then how to get the lower nibble from 0x35? So to get the lower nibble from 0x35, I have to do byte and with 0x0f. So I'll get 00000101. Okay, I will get the lower nibble. Now if I directly have it returned to port D like this, okay, so whatever lower nibble I am writing will be given from RD0 to RD3. So this takes RD0, this will go to RD1, this will go to RD2, this will go to RD3. But RD0 to RD3 I am not at all using. So whatever this lower nibble is there, it has to go from RD4 to RD7. Okay, it has to go from RD4 to RD7. So I right shift it for 4 times, which ends up giving me 0101 and 0000. In that case, if I now write this to port D, don't you think I'm going to write four, this 5, the lower nibble from RD4 to RD7? Am I not writing the lower nibble from RD4 to RD7? Yes. So in that case, I'm done giving the upper nibble first. I then gave the lower nibble from RD4 to RD7. I clocked the enable. Then I'm giving a delay of 4.1 milliseconds so that the CLCD is taking its time for processing. Okay, that's the only difference we are making. Okay, so this is how I'm going to have the 4-bit mode configured. One after the other it will write. No, yeah, like first you will write the upper nibble, then you will write the lower nibble, then you will let the CLCD process the data. Repeat once that, left shifted for 4 times. Okay, once I do this byte and with 0x0f, I will end up getting the lower nibble. But if I directly write it to port D, whatever lower nibble is there, that will be given from RD0 to RD3. But I'm not using RD0 to RD3 in my data transmission. I'm using only RD4 to RD7 of my microcontroller. So to let this lower nibble go via RD4 to RD7, I have to left shift it for 4 times. So then if I assign it to port D, the lower nibble is going from RD4 to RD7 pin of the microcontroller. Okay, so that is it. Nothing else is different from the previous case. Let me just build this and show the output. Load hex. So if you have to identify whether the CLCD has been configured in 4-bit mode or 8-bit mode, you can just look at the CLCD write function. If CLCD write function has a data return in one shot to the port D, then it is configured in 8-bit mode. If the data is returned for 2 times, like upper nibble first, then lower nibble, then CLCD is configured in 4-bit mode. So you can see one being displayed on line 1 4th position and world being displayed on line 1 line 2 4th position. Clear? Okay. So this completes the next peripheral of the module, which is nothing but CLCD. The next we have got is matrix keypad to be discussing about, which we will do it in the next class. So there is no class tomorrow. We are going to meet in the next class, like maybe Tuesday, because Monday is a holiday. So we are going to meet it on Tuesday. Meet you people back on Tuesday. Okay, so I've got enough time. Please make sure you are paying attention, you are finishing off your assignments and submitting them on time. Okay, so here is your QR. Please have your attendance marked, then quit. Thank you all. We'll continue on Tuesday with matrix keypad.